Hello, this is the last video in this section, and in this one I will show you a very elegant inequality which can be proven in an even more elegant way. Let's start. Proving inequalities without using induction, problem number 3 in this section. And here is the text of this problem. Prove that for each natural number n, we have this inequality. And you know what? This inequality is even true for any real number n. So if you see the proof, you will understand why. So what can I do here? I can write like this, that this is equivalent with another inequality in which I subtract 2n from both sides of the inequality. So if I subtract 2n from this first side, I can write it strategically here. Plus 1 is greater than or equal to 0, right? I have subtracted 2n from both sides. It's perfectly legal operation. If you subtract the same number or the same expression from both sides of the inequality, inequality remains. And now, you see, you can rewrite it in the following way, that this is equivalent to the fact that n minus 1 all squared is greater than or equal to 0. And we are done, because each square of each real number is 0 or more. So this is simply always true, even for n which is just any real number, not only natural number. But maybe you wonder what has happened here. Well, what has happened, I applied the formula for the square of difference. So the formula is a minus b all squared is equal to a squared minus 2ab plus b squared, and I applied this formula with a equal to n and b equal to 1. Then you get n minus 1 all squared is equal to the first one squared is n squared, minus double product is minus 2n, and then plus the second one squared. So this is simply always true. And this inequality could be proven with help of induction, but it would be complicated. It's not a good example of a problem which is, because you have to consider cases, it's not really good problem for induction, but it's really a very nice problem to solve this way as I showed you. And you can prove many other inequalities, much more complicated than this one, using a similar trick, but this would be an entirely different course. Don't go yet. I still have some slides to show you, because there is still section number 3, and in this third section there is a bunch of articles which I have written especially for you. I did my best to describe everything so that you can understand without my help. So now I will show you what you can find in the next section. So in lecture 12 you have an article about infinite periodic decimal expansions. In lecture 13 you find an article about infinitely repeating continued fractions. This is a topic which is usually not a part of curriculum at schools, so it will be probably new for you. And in lecture 14 you find an article about infinitely repeating square roots. And then the very last lecture in this course is lecture number 15, which is a bonus lecture with information about our paid courses and about coupons which you can apply in order to get a sales price at any times. Okay, so thank you for watching, and I really hope that you will look at section 3, because I put a lot of work in these articles. I did it especially for you, and don't forget to watch the bonus lecture. Thank you for watching. Bye bye.